Hello everyone. Welcome back to Dr. Lu's VCE Chemistry channel. Today, let's learn together about the 2019 VCE Chemistry examination. We will focus on questions related to equilibrium and rate of reaction. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Le Chatelier's principle is used to predict the equilibrium position when the condition is changed. Catalysts cannot influence the equilibrium position, so A and B are eliminated. Temperature changes could influence the rate of reaction, but Le Chatelier's principle cannot predict the effect of this change on the rate of reaction. So, C is eliminated. Le Chatelier's principle can predict the effect of changes in the concentration of reactants on the position of equilibrium. So, D is correct. The keyword is reverse. So, we should reverse the energy profile. Then, we find that the final product energy is 50 and delta H is positive 10. Ask the method to reduce the rate of reaction. Changing the diameter or volume but not changing the concentration does not influence the rate of reaction. So, B and D are eliminated. An increase in the temperature could increase the rate of reaction, so C is eliminated. Mixing a dilute solution of sodium hydroxide with ethanol could decrease the concentration of ethanol, so this method reduces the rate of reaction and B is correct. We know the concentration of reactants and products, and the equilibrium constant, so use the equilibrium constant equation to calculate the equilibrium concentration of SO3 step by step. The shape or position of the original distribution curve is not affected by the presence of a catalyst. However, the activation energy is lowered. The curve does not flatten or shift to the right, so statements 1 and 2 are incorrect. Yes, the activation energy is decreased and shifts to the left because a catalyst decreases activation energy. So, statement 3 is correct, and we should select D. At time T1, the mixture is heated. The concentration P increases while Q and R decrease. So, P is on the endothermic side, and both R and Q are on the exothermic side. B, C, and D are eliminated because R and Q are on different sides. In option A, P is on the endothermic side, and both R and Q are on the exothermic side. So, A is correct. Calculate the equilibrium constant of the reaction one by one. To get the correct unit of the equilibrium constant, please substitute the unit of concentration into the formula. All values are 1, but only the unit of reaction 2 conforms to the negative quadratic m. The key point of the question is the unit of equilibrium constant. The cobalt tetrachloride ion is blue. The cobalt ion is pink. The intensity of the pink is measured. As the temperature decreases, the pink increases. The forward is an exothermic reaction. As the temperature decreases, the pink increases. The cobalt ion is pink. So, the concentration of cobalt ions increases. The lower temperature pushes the forward reaction, so, the forward reaction is exothermic. The final color is darker than just after the water was added but lighter than the color at the initial equilibrium, and not quite as pink as before the change. Adding water decreases the concentration of all species. The system partially opposes this change, favoring the reaction producing more particles in aqueous solution, the forward reaction. The concentration of cobalt ions at the new equilibrium is less than before the addition of water but greater than after dilution. Dilution decreases the concentration of all species in the reaction, so the system responds, favoring the reaction that produces more particles to increase the overall concentration. 5 drops of silver nitrate solution are added to the equilibrium mixture at time T1. Silver ions push down chloride ions as silver chloride, so the concentration of chloride ions decreases first. Then, the cobalt tetrachloride ions dissociate into the cobalt ion and chloride ions to compensate for this decrease partially. So, the concentration of cobalt tetrachloride ions will decrease and cobalt increase. The changes in cobalt tetrachloride ions or chloride ions are just 1/4 of changes in chloride ions. Seven multiple-choice questions are worth 7 marks, and one short answer question is worth 7 marks in equilibrium and rate of reaction. The overall score for this section is 14 marks. With a total possible score of 120 points, the percentage for this section was 11.7% of the total score.
If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel, Dr. Lou's VCE Chemistry channel, and Dr. Lou's VCE Biology channel.